All right. So children, will get into it, right? Because we're short on time. The first three questions I'm not going to explain too much. I'll straight away go to the answers. So the order of the matrix that they're asking for the first question. Now, since some of you haven't got the paper, I'll just write the matrix down. So the matrix they've given is -9, 6, and -3, right? They're asking what is the order of this matrix. The order, children, is 1 by 3, right? Because there is only one row and three columns. Children, this is called a row matrix, right? A row matrix, right? Also, children, for matrices, you may see square brackets. That is also correct, right? So don't panic if you see square brackets, because some people write matrices in square brackets. Even I write square brackets, right? But mostly in your books, you will see normal brackets for matrices.
Any bracket is okay. Yes, any
Yes,
bracket is okay, children. Don't worry about the bracket.
bracket. That is right. Okay, so children, question number 2, it says, what is the order of a matrix which has an equal number of rows and columns with 4 elements? So children, equal number of rows and columns means a square matrix that has 4 elements. So the answer is a 2 by 2 matrix, right? Because a 2 by 2 matrix will have 1, 2, 3, 4 elements, and it will have the same number of rows and the same number of columns, right? That is the answer to the second question. Next, children, it says a manufacturer of computers makes laptops and desktops either in black or white cases. So there are 10 black laptops, 20 white laptops, 4 black desktops, and 15 white desktops. Write this information in a table and then in matrix form. So children, I'll write it like this. So we'll have laptops and we'll have desktops, right? Then we'll have black, then we'll have white. So I hope you can read my quick handwriting, right? So children, you can switch these columns and rows as well, but we usually put the more important one at the top. Am I right, Dilani teacher? So
Yes.
laptops and desktops would usually go on top, but you can switch it there as well. I don't think you lose a mark, right? So there are 10 black laptops, there are 20 white laptops, then there are 4 black desktops, and there are 15 white desktops. So children, if you put this into a matrix, it will be 10, 4, 20, 15. This is what it will look like. All right, so that will be the answer to question number 3. Then children, now from question 4 is the part which I really want to focus on, so I'll quickly write these down. So in question 4, they've given us two matrices, children. So the first matrix is 6, 1, 5, 2, 3, and 4, and matrix B is 1, 3, 2, 0, 2, and 3. So part A, they want us to add the two matrices together. All right, so when you add them together, children, you basically add the same places together, right? So we'll write it again. So 1, 3, 2, 0, 2, 3, right? So what happens? You get 6 plus 1, that is 7, 4, 7, 2, 5, and 7. This will be the answer, children, right? For part A, where you add matrices A and B together. All right. Okay. So children, quickly take a screenshot, right? I'll also go to, I'll actually use these same things because I'm a bit short on time, right? So the next part is B minus A. So I'll just move this to the back, right? Okay, so B minus A, children, right? B minus A. So I subtract all of the elements from of B from A, right? Yes. So basically 1 minus 6 gives us -5, 3 minus 1 is -2, 2 minus 5 is -3, and 0 minus 2 is -2, 2 minus 3 is -1, 3 minus 5 is -1. So this is the resulting matrix. No, this is not -2, this is +2, right? 3 minus 1 is +2, the others are all negative, right? This is the answer to part 4b. Okay, then children, we have part C, for which Now this one is a little more tricky, children, right? So I'll clear this as well. So this one is 3a plus b. So children, 3 times 6, 2, 1, 3, 5, 4 plus 1, 0, 3, 2, 2, 3. Right? So children, you have a scalar multiplication first. You can see that, right? So we first multiply matrix A by 3, which gives us 18, 3, 15, 6, 9, 12. Right? Plus 1, 3, 2, 0, 2, 3. Then children, you can add the two matrices together. So that gives us 19, 6, 17, 6, 11, and 15. All right. Yes. So that is the answer to part 4C. All right, children. Okay. Then, so I hope this is okay, right? Next, children, let's go on to question number 5. All right. So children, in question number 5, we have to multiply the two matrices together. So the matrices are 3, 2, 1, 6 times 5 and 4, right? So when I multiply the first row and this column, so children, we only have one column, isn't it? Right? So that's going to be 3 times 5 plus 2 times 4, right? So children, we don't have another column anyway, so we just go to the next row, right? So that is 1 times 5 plus 6 times 4. Okay, so 3 times 5 is 15 plus 8 and 5 plus 24, right? So this gives us 23, 29. That is the multiplication of these two matrices. And also one more thing we can have a look at is that this is a 2 by 2 matrix and this is a 2 by 1 matrix. This can be multiplied, right? Because the number of columns on the second one is equal to the number of rows on the first, and the answer should be a 2 by 1 matrix. All right, so that's how you get the answer to part 5a. All right, so children, we're over time, but I'll quickly finish the paper, right? So then when we go to the next question, it is our matrices are 3, 4, 1, 6, and we have 4, minus 1, 2, and 2. So children, these are both 2 by 2 matrices, and as you have seen before, they can be multiplied, right? So I have the first row, first column, let's multiply them. So I get 3 times 4 plus 4 times 2. So that is my first element, children, right? Then for the next element, I go with 3 times negative 1 plus 4 times 2, right? Then I go to the next row and again the first column. So that is 1 times 4 plus 6 times 2, children. And finally, I go to the last column, which is 1 times negative 1 plus 6 times 2. Okay, so that is my multiplication done. So 3 times 4, that is 12, plus 8, and 1 times 4 is 4, plus 12, and negative 3 plus 8, and negative 1 plus 12, right? So the answer would be 25, 16, 11, right? This would be the answer to part 5b. Okay, so we have one question left, children. Quickly take a screenshot of this. This last question is the most interesting question, right? So let's have a look at that one. Okay, so I hope all of you took some screenshots, right? Okay, so children, real quick, let's go to the last question as well and we'll finish off for today. So children, the last question says you've got two matrices, 2, 3, 1 minus 1, and another matrix 1, 1, x, negative 1y 4, right, equals to another matrix, so negative 1 2 z 1 16 negative 2, right? So they want us to find the values of x, y, and z. All right, so how would you find the values of x, y, and z? So children, the first step is you multiply the first two matrices together, and let's just check whether they can be multiplied, because the dimensions look a little weird, don't they? So this is a 2 by 2 matrix, and this one is a 2 by 3 matrix. So turns out, children, you can multiply them together, right? The number of columns on the first is equal to the number of rows on the second, right? So, and the resulting matrix will be a 2 by 3 matrix, which is also correct. You can see the result is a 2 by 3 matrix. All right, so let's multiply the first two matrices together and see what we get. So children, we'll start with the first row and the first column. All right, so 2 times 1 plus 3 times negative 1, right? So then we can move to the next column, so that is going to be 2 times 1 plus 3 times y, that is just 3y. I'll keep it as 3y. All right, and then 2 times x, which is 2x, plus 3 times 4, children. Right, now we have finished all the columns, so let's go to the next row and the first column. All right, so children, 1 times 1 plus minus 1 times minus 1. Okay, let's go to the next element, which is in the next column. So 1 times 1 plus negative 1 times y. Okay, then finally, children, we'll go to the last column, so that's going to be 1 times x, which is just x, plus negative 1 times 4. Okay, so this is our matrix. Now you can see this is quite large, right? So let's simplify things and see what we get, right? So children, I'll just do one step here, right? So we have 2 minus 3, that gives us negative 1, and then we have 2 plus 3y, okay, and then we have 2x plus 12, then we have x minus 4, and we have 1 minus y, and here we have 2. Okay, so children, this is what it simplifies to. Now children, you can clearly see that this should equal the matrix that they have given in the question. Can you see? So you can already see that some of the elements are already true. For example, negative 1 and negative 1, that is correct, right? But there are some elements which we can't find because they have x, y's, and z's. So that's how you can actually find the values of x, y, and z. So for example, children, you can see that negative 2 should be equal to x minus 4. Can you see that, children? Right? So negative 2 should equal to x minus 4, which means that x is going to be equal to 2. So this is how you actually find the values, children. All right, then you can find y easily by taking that 1 minus y should be equal to 1. Remember, children, the corresponding elements should be the same, right? So 1 equals to 1 minus y. So that means, children, we get y equals to 0, right? And finally, to find z is going to be the easiest, I think, of the lot, because z is directly equal to 2. There's nothing that you have to do, no calculations, right? So children, x is 2, y is 0, and z is equal to 2 as well. So these are the answers.